Assalamualaikum. My name is Syed Muhammad bin Syed Alwiya Junid and I'm from RK86. I'm the leader of MicroSenior group. Today, me and my team members are going to present Smart Water Pollution Monitoring System SWAP MS. First, I'm going to introduce my team member. First, Muhammad Amirul bin Muhammad Anwar from RK86. Next, Muhammad Shamil Azril bin Samsul Sham from RK05. Then Neo Siu Ping from RK05. Shamil and I designed the system and programmed the board. Then Neo Siu Ping and Muhammad Amirul did the prototype testing and prototype development.
Hello, my name is Muhammad Syamil Adril and I will tell about introduction. Okay, project background. Nowadays, our country has been affected by the water pollution, which is caused by human activities. Water is the most important resources in our daily use. Water that had been not be treated can lead to various diseases. So the water system is needed to be monitored in order to overcome water pollution. Nowadays, in our modern technology, water system can be monitored with using IoT with microcontroller. Okay, for our project prototype, which name is Smart Water Monitoring System (SWAP MS), can monitor real-time water quality. There are three types of sensor that we used in our prototype, which are pH sensor that can be used for monitoring water pH quality. Secondly, temperature sensor for monitoring temperature difference in water. Thirdly, ultrasonic sensor is used for water level measurement. Our project is also portable and unmanned autonomous vehicle, which can be remotely controlled and the data can be acquired by the web server. Okay, then objective. We will be focusing on four main objectives. Our first objective is to investigate the related existing system that's suitable for this project. Secondly, to develop a system that can monitor water quality. And thirdly, to analyze the water quality data from the web server. And lastly, to provide an eco water quality tracker. Okay, for project scope. Our project scope is to monitor water quality with a small, low cost and unmanned boat to acquire data like pH, temperature, and water level in real water resources such as ponds, reservoir, and lakes. The classifying of the data that we taken from the this place will be based on water quality index (WQI). Okay, the water quality is determined by Department of Environment, which refer from the water quality index. Furthermore, most of the part that we made, which is the prototype, is made from the recycled product. Then problem statement. Okay, mostly problem statement that we encountered for this project is related to the pH sensor. The pH sensor have a lifespan which is around half year, which can result to frequent maintenance and lead to higher costs. Other than that, our pH sensor has a sensitive probe, which cannot stay in the liquid for a long time.
For the methodology, um, this is our flowchart for overall process flow. We start our project with reviewing journal and research paper. Then we design the system based on the schematic and idea from our supervisor. Then we develop the code based on the system design. Then if it's not working when we test it, when we integrated it, we have to troubleshoot it. After that, if everything works just fine, we proceed to our prototype. The prototype, we create a casing for it. We make a RC board to test in the Unimap Campus Pau open water area. Then if we test it, if it has the problem, we have to troubleshoot it. Then we have to test it again until it's working. Okay, these are the list of component for project, which is not MCU, ESP8266, which acts as a microcontroller. Then we have the waterproof ultrasonic sensor. We also have the gravity analog pH sensor, and lastly we have the DS18B20 temperature sensor. The cost for all of these component is 228 ringgit 80 cent. We use Arduino before this pandemic. We use Arduino, then we expected that the result. Okay, this is our system design, which we use not MCU as a controller. Then we use temperature sensor to detect water temperature. Then we also use ultrasonic sensor to detect the depth of the river or pond. Then we use the pH sensor to detect if the water is acidic, neutral, or alkaline. This can be used in. Then we record to database, which is in Excel file. This is the block diagram for our system design. Okay, this is the schematic. First of all, we have the ultrasonic sensor. This is not the ultrasonic sensor that we use, but the connection is the same. We can use this ultrasonic sensor or the waterproof one. Then we have the pH sensor and temperature sensor. pH sensor is in analog value, while the temperature sensor and ultrasonic sensor is in digital value. So then we use the battery, which is 3.6 volt, to power up our non-MCU. This battery can be rechargeable. It can be recharged. We can also substitute it with the solar panel, and this can make our project much more green. But due to this pandemic, we didn't manage to get the solar panel. Okay, for software development, we use Arduino IDE to program .mcu. This software is used. This software use C or C++ or Java as a programming language. It's an active development of the Arduino software, which is hosted by the GitHub. The GitHub is the programming community, which we can use to find codes or gain knowledge about programming, gain knowledge on firmware, hardware, everything. Okay, it's an open source. This software is an open source software, and it's easy to write code and upload it to the board. Okay, now for the web server. Web server is a place which stores, processes, and delivers web page to web client. The web client is a web browser on our laptop and the smartphones. We can also use tablets. The communication between client and server takes place using a special protocol called Hypertext Transfer Protocol (HTTP). This is the picture of the web client and web server communicating through the HTTP. Okay, here's the operations mode for .mcu. This .mcu can connect to an existing Wi-Fi network and act as a web server. It can also set up a network on its own, allowing other devices to connect directly to it and access its web page. Then ESP8266, which is not MCU, can operate in 3 different stages, in 3 different modes. which is station modes, STA modes, which is STA modes, soft access point, AP modes, and both. You can also do both at the same time. We tested using both and it works accordingly. It works as we can see here in STA modes, which if you realize that we have the Wi-Fi router here and we have a not MCU server. This ESP8266, this mode is used to connect ESP8266 to the Wi-Fi network established by an access point. Now we have an access point, soft access point modes, which an access point is a device that provide the Wi-Fi, which we use from the STA mode here. We gain it from the Wi-Fi router to the Node MCU. Then we have the Node MCU and the Node MCU server as the Wi-Fi access point AP modes. We can use both modes. Actually, we use the third modes to create the web server. The maximum number of station connected to the access point is around 5. Only 5 things can connect to Node MCU server.
Hi, my name is Siu Ping. Now I'm going to present the project design consideration of Smart Water Pollution Monitoring System, which is also known as SWAMS. For the project prototype construction, our group had used fill material as listed below. First, plastic bottle is used because of its lightweight and cheap, which can act as a support for the device to float on the water. Second material we use is acrylic perspex, which we use it as a body part for the device. This perspex is transparent, which allows us to easily see through the component inside the device. But in real life, the body part is preferable in opaque. Next is solar panel, which is a renewable source and can help to reduce the usage of electricity and reduce the electricity bill. Our group planned to use the solar panel at the first place, but due to some unavoidable constraint, we had changed the power supply by using rechargeable battery. But we still remain the concept of green technology. The next material is motor, which is a rotary electrical motor that converts direct current electrical energy into mechanical energy. Then the last one is fan, to give a thrust force for the device. So here is the virtual 3D design that we had planned at the first place by using 3D Paint software. There are 3 sensors we are using, which had already explained in methodology section. We had also considered the health and safety aspect regard to this smart monitoring water pollution system. This device is an eco-friendly product. This device uses solar, which is a renewable source and will not execute any harmful toxic gas, as it do not implement any fossil fuel. Next, safety feature and guideline for operation is provided. It can be operated easily because of its simple design. Users should follow the safety regulation endorsed by the authority. This product is safe if the user follow the precautions stated by the authorities. The constraint of our group faced is related to the budget. We are not effort to implement the solar panel due to price is over our budget. Hence, we had replaced the solar panel with rechargeable battery. Furthermore, due to current condition, which is COVID-19 pandemic, we only able to do discussion through online platform, which is the biggest obstacle for us to do a group project.
For result and discussion. Okay, this is our component testing. We test waterproof ultrasonic sensor. We also test gravity analog pH sensor, and we also test DS18B20, which is the waterproof temperature sensor. The waterproof, the pH sensor, the ultrasonic pH and temperature sensor are accurate before the pandemic happened. We test it before the pandemic. Then this is the system integration and testing. We test it on the plain water in the beaker. Then we displayed it on the serial monitoring in Arduino IDE. Okay, this is the web server that we made, which shows the temperature, the distance, and the pH level of the open area, open water area in Unimac in campus Power Unimac. Okay, it also shows the water temperature graph and the pH level. Okay, to access this server, we must know how to get the IP address from ESP8266. ESP8266 act as a AP access point, which we need to find which came from the hotspot, connect to the ESP8266, which is an STA. Then we use it to access the web server. We combine the STA modes and the AP modes. Okay, then to access the server, we must get the IP address here. To get the IP address, in iPhone, we can use iNet to detect the IP address around it. That's how we get this server. That's how we access this server. Then we have the database for our project. The database was generated in Excel file. The results. This is our result with the timeline. Shows the temperature and the pH level only. We only extracted these two. Okay, this is the prototype testing which Amiro did. We have to send the system to him to create the prototype. Due to this pandemic, we have to post it to him. Then we get the reading pretty accurate. The river of Unimac is pretty acidic actually. Now for the demonstration.
Hi, hello everyone. My name is Muhammad Amiro bin Muhammad Anwar, and I'm going to be presenting about the smart water monitoring system. In short form, is SWAMS. So the smart monitoring water system consists of the pH sensor, which is located on this side of the prototype. So you can see this is the pH sensor. So on the other side, this is the temperature sensor, and right beside is the ultrasonic sensor. So the way this prototype works is that we're going to put it on any open surface water, which is now we are doing it on campus power, on the lake beside the park. So we're going to test it here. So when we power up the circuit, it is going to send information and data through phone, which is on a server, which will display the result of the pH, the temperature, and the range of depth inside the water. So this way we can know the quality of the water. So we are going to test the prototype now.
Okay, ni first reading. Ni first kan?
Alright, ini reading yang, this is the first reading. So the water level, pH level is 5, distance is 18.46, and the temperature is 32.44. So we're going to move it about 5 cm apart and take every reading. So right. Distance dia tak pakat lah. So the pH level is 5.04 there, and the temperature is 32.63. So the distance, it doesn't make sense. You know, maybe some sorts of error.
1 meter. Make sense lah. 1
So
meter.
the distance is around, alright. So 129.61 centimeter. We're going to proceed over 5 more meters. Okay.
Bateri oh. Aku rasa aku syorkan jangan test jauh sangat.
So ada jauh sangat tu.
Aku rasa dia punya signal tu, signal dekat tu. Ha.
Jauh.
Wih. Anda jauh ni ya.
So at this locations, the temperature is 32.63 degrees Celsius and the distance is 18.27 centimeter, and the pH level is 5.12 pH. So in conclusion, the quality of this water is around more to acidic, closely to neutral, and the depth of this surface water surface is around to 15 to 25 centimeters. As you can see, here is the graph, shows that there are no current spike except for when we put the boat inside the water. So it has a early spike. So the reading is mostly average along the way, by time. Jalan lagi. Dia tenggelam ni. Okay, so in conclusion, the result obtained is fairly accurate. So there are some technical difficulties, which is that when we send the boat more than 20 meters, so it lost connection, but mainly due to its sensor, where it didn't detect the water level. So it lost connection during half of the test, but still the circuit still projects the reading, so we can still get the reading, the pH sensor pH reading, the temperature reading, and the depth reading. So basically, yeah, the data received is fairly accurate. So to demonstrate here, so after receiving it, there were no known difficulties. So the photo still can work properly and send the signals properly. So here is an example of the test. So here it is. So you can move left forward, and you can even go reverse. So because it is too overweight, so it it can't go reverse properly. So mainly it can go forward, left and right. So if I switch to look at the back of the board, so here no, so it can still go left and right. So I don't know, difficulties that the roboter is working properly, right? So that's all. So from the data gathered from the experiment, so it will be analyzed later, and data will be properly analyzed and in average. So that is all from me. So thank you. Final one. You can't go anywhere anymore. So that's all. Thank you.
As a conclusion, SWAP MS managed to monitor water quality in open water area at campus Pau Unimac. The pH and temperature sensor are used to measure the pH and temperature of the water. The output parameter were displayed on web server. Okay, the ultrasonic sensor also displayed the reading on the web server. This sensor measures depth of open water area in Unimac. The SWAP MS provides an eco solution for water quality monitoring with a low cost solution because we only use Node MCU. As a controller, we didn't use any other such as Arduino and Raspberry Pi like the previous work because the cost is much more lower than the existing project and all of the objectives have been achieved. Okay, for future work, we propose the surface monitoring, which we can use to detect the unwanted substance in the water by using a camera. This camera can be trained by using a machine learning to detect foreign or unwanted substance in the surface of the water. Okay. Water pollution solution. We can use a net or robotic arms to collect waste in the water with the combination of the surface monitoring. And that's all for our project.